So this is an example for electric field. The charge Q1 is 7 microcoulombs and is at the origin, while charge Q2 is 5 microcoulombs and is on the x-axis 0.3 meters from the origin. So you can see here Q sub 1, which is in violet, and Q sub 2, which is in blue. So the distance between them is 0.3 meter. So let that be the R between 1 and 2.3 meter. So we have to find the magnitude and direction of the electric field at point P, which is in green, which has coordinates 0, 0.4 meters. So it's on the y-axis. Okay, the distance from 1 to P is 0.4 meter. So after finding the magnitude and direction of the electric field at point P, so we have to find the force on the charge 2 times 10 raised to the power of -8 coulombs placed at point P. So we're going to replace point P with a charge. So what force must that charge experience? Okay, I'm saying that electric field at point P. First, we need to find the distance between the charge 2 and point P, because we're going to need that for the electric field later. So solve for R to P. So P, Q1 and Q2, as you can see, forms a right triangle here. So if this is 0.3 to 0.4, then this must be 0.5 meter. Let's show the solutions. So this is the distance between charge 2 and point P. So this is equal to the square root of 0.4 meter squared plus 0.3 meters squared. So the distance between these two particles is square root of 0.4 squared plus 0.3 squared, or that's 0.5. Okay, so next, for the electric field, since we have two charges causing electric field, so we need to add the two. But first, we need to know the direction of the electric field. So for electric field caused by the first particle, Q1, it is positively charged. So the direction of the electric field is away from the charge. So for the electric field at point P caused by P1, or rather by Q1, so it's this arrow pointing upward. So we'll just label it as E sub 1. While for Q2, the electric field is also away from it because it's positively charged. So take note that the arrow must be in the same line with P and Q2. So it must be at this direction. So I'll label it as E sub 2. Since it's located on a quadrant, we need the angle, okay, between E sub 1 and E sub 2 for the components later. So that angle, by the way, is just equal to, let's form that line here, and for E1, let's just measure from the x-axis so that it could be automatically cosine for x component and sine for y component. If we measure it from here, okay, this angle okay, basically is just basically the same angle here. Okay, so let's solve for theta. Let's label it as theta sub 2. So theta sub 2 is arc tangent of the opposite side, which is 0.4, and the adjacent side is 0.3. So that would be, make sure that the calculator is in degree mode. So arc tangent of 0.4 divided by 0.3. So it would be equal to 53.1310235. Let's just round up to the fourth decimal place. 3.1301 degrees. Okay, or in standard position. Standard position. It's in the second quadrant. So we need to add 90, or rather, we need to subtract it from 180 because we are measuring from the negative x-axis. So it must be 180 minus 53.1301 degrees, or that would be equal to minus. So it's 126.8699 degrees. Okay, this is again for the angle for E2, right? So next is we need to solve for the x component of the total electric field. Let's just label that as E sub x. So it would be E from the first charge. Okay. It's x component plus E from the second charge. Okay. X component. So for E sub 1, it's pointing upward. Basically, it has no x component, right? 0, or you can write E sub 1 times cosine of 90. That's upward, so meaning the angle in standard position is 90 degrees. And cosine of 90, take note, is 0. Okay, so meaning there's no x component. It's purely vertical. Okay, so it's 0. Then the second electric field along the x-axis is from the magnitude of electric field at point P caused by Q2 times cosine of theta sub 2. It's going to be 0 plus, this is K times Q2. Okay, take note, just the magnitude of Q2, and then over R squared times cosine triangle. So that's 0 plus, we have 9 times 10 raised to the power of 9 Newton meter squared per column squared over R, which is 0.5 meter squared times cosine of 126.8699 degrees. Okay, or you can have 0 minus 9 times 9 divided by 0.5 squared cosine of 53.1301 degrees. You want to put the negative sign yourself. But if it's already in starting position, so all you have to do is just to add everything. Okay. All the x components. So we have total electric field along the x-axis. So we have 9 times 10 raised to the power of 9, then times cosine of 126.8699, then divided by 0.5 squared. So it's negative 2.16 times 10 raised to the power of 10. Okay, that would be in meter squared is cancelled out. Okay. And we still have the Q2. Sorry for that. I forgot to write the Q2. So let's K times Q2, which is 5 micro coulombs, or 5 times 10 raised to the power of negative 6 coulombs. So let me put that here. So it's very important to check the dimensions. So when I check the dimensions, it's Newton per column squared, and E must be Newton per column. So the reason is there's no Q2. So I forgot to write the Q2. So it must be times 5 times 10 raised to the power of negative 6. It must be negative 10,000 or 108,000.0059, not negative 2.16. We'll change this. Negative 108,000.0059. And it's now the correct dimension, the correct unit, Newton per column. So next is solve for the y component. So E sub y is equal to E sub 1 sub y plus E sub 2 sub y. Okay. So we have E sub 1 y. It's actually the entire 2 sub depend entirely on the 2 sub 1, the total electric field. Okay, because there's no x component, so E sub 1 y is basically just equal to E sub 1. Okay, I'll just write that as E sub 1, okay, sine of theta sub 1 plus E sub 2 sine of theta sub 2. So that would be K times Q1, okay, over R, the distance between 1 and point P. So let's say this is R1P. Square that times sine of theta sub 1 plus K Q2 over R sub 2P squared sine of theta sub 2. So we have a common factor Q. Let's just put it once. Q1 over R sub 1P squared sine of theta sub 1 plus Q2 over R2P squared sine of theta sub 2. We plug in the values. We have 9 times 10 raised to the power of 9 Newton meter squared per column squared times Q1 is 7 microcoulombs. So 7 times 10 raised to the power of negative 6 coulombs, okay, over the distance between 1 and P is 0.4 meter. 0.4 meter. Okay, quantity squared times sine of 90 degrees. Then plus Q2 is 5 microcoulombs. So 5 times 10 is 1 negative 6 coulombs divided by 0.4 R P. So it's 0.5. Meter quantity squared times sine of 126.8699. Okay, so we have, so that it won't be very long, the calculator, so we can first do this. 7 times 10 is from negative 6 times sine of 90. Then divided by 0.4 squared. That's the result for the first term inside the parentheses. Then add, if you want to use this, 5 times 10 raised to the negative 6. Okay, times sine of 126.8699. Okay, then the denominator is 0.5 squared. And don't forget to multiply with 9 times 10 raised to the power of 9. So that's 537.749. 537.749.9956. That would be newtons per coulomb. So newtons will be cancelled out, and then meter squared also, and one of the columns we have newton per coulomb. And of course the resultant. So for E, the square root of the square of the x component plus the square of the y component. So we have negative 108.0059 newton per coulomb squared plus for the y component it's 537.749. 537.749.9956 newton per coulomb quantity squared, or that would be equal to, square this plus square of 108. Sorry, it's 108,000.0059 plus 3 zeros after 108. 0.059, 0059, right? 0059. And the square root of this is 548,487. 548,487.975 newtons per coulomb. This is the magnitude. Okay, we need to solve for the direction. So for theta, it's a vector quantity. So arc tangent of the y component over the x component. So the x component is negative, so means to the left, and the y component is positive, so means to the right, upward, I mean. So the resultant is on the second quadrant. So it's arc tangent, it's measured from here, from the negative x-axis. So the angle that we're gonna get is this angle. So arc tangent of 537.9956 divided by negative 108,000.0059. So the newtons per coulomb are cancelled out. So that would be that value divided by, I'm sorry, not that value, that's for the resultant already. So arc tangent of 537.7499956 divided by negative 1,000.0059, so that would be negative 78.644. It's negative because it's measured from negative x-axis, and then the rotation is clockwise. So that one. Or in standard position, that would be 180 minus 78.644 degrees. So that is equal to 180 plus the answer, plus the negative sign. It's a negative 78.644, so it's 101.356 degrees. So this is the direction. So next, for letter B, find the force on a charge of 2 times 10 to the negative 8 coulombs. So we're going to put a charge here instead of just labeling it as point P. So put a charge here. So what force will it experience? So this is for letter A. For letter B, so we have E is equal to F over Q, right? So we need the force. The force is actually the product of electric field and charge. So if the charge is 2 times 10 is negative 8 coulombs, we're going to multiply that with the computed value of E, which is 548,487. 548. It's on the calculator, so let's just put it here. This one, 548,847. 548,847.9753 newtons per coulomb multiplied by the charge, which is 2 times 10 raised to negative 8. So cancelled out. We have newtons. So multiply this. So we need to input again that value, because if you press A and S, it will get the most recent value, which is, I think, the angle, not this one. 548,847.9753 multiplied by 2 times 10 raised to a power of negative 0.011. If rounded up to the fourth decimal place, 0.01 Newton. So that force, 2 times 10 raised, or that charge, 2 times 10 raised to negative 8 coulombs, will experience a force 0.0011 Newton because of the two charges.